let's go over iomanip. So there's two things that we've kind of been using so far, and that's when we're using cin. We use this thing called the input stream. And all the input stream is a sequence of characters from an input device to the computer. We've also been using cout, and that uses the output stream. And the output stream is a sequence of characters from the computer to an output device. So we can't really do much with the input stream minus take in input from people. But we can manipulate the output stream with iomanip. And what does that mean? Imagine you have like an array of numbers, or a matrix of numbers, like 1, 2, and down here you have, let's say, 23, 7, and then you have like 1, 5. And you want to output that to the screen nicely so that you have one column of these and one column of these. But as we've done it so far, what you would get is 1 space 2, and then you would get 2, 3 space 7, and then 1 space 5. So this 2, 3 would push this 7 over, so it wouldn't line up nicely here. So how can we make it so that these push these over to fit this 23 so that these all line up nicely? Well, we can use iomanip, and specifically we can use the, setw function, predefined function. And what that's going to do is set the width, and you need to send it in integer. And what that says is I can go cout set width, 2, 1, 2. What this is going to output is a 1. It's going to output a space here. Well, actually, we would want to actually put a space here, and then 2. And we should also have an end line. Then let's also say cout set width to 23 space, what was the number I used? 7. End line. What this is going to do is it's going to format our output stream so that it's going to give whatever follows this setw 2 spaces in the output stream. So it's going to allocate 2 spaces for whatever comes next in the output stream. So it's going to put that 1 there. And then it's going to put this space right here, right there. And then it will put this 2 right here in its own space. So then when we come down to this line, it's going, the setw will say, all right, I want to put, oopsies, I want to allocate 2 spots for whatever comes next. And then you can put that there. And then put this space here. And then put the 7. So that it will nicely line up these columns. So let's see that on the computer. So let us include iomanip this time. And let's say we want to see out 1 space 2. And then see out 23 space 7. Oh, we need to add the end lines here. Then we can save this. We can compile our program. We can then run our program. And you see this 7 gets output offset like that, just like we would expect it to. But what if we want it to line up? Well, we just come here and we put setw 2, put another insertion operator. And technically we don't need to put one here because the 23 is the width of 2, but like, let's just put one here for continuity. So then we can compile our program and run it, and you see, cool, everything is lined up how we want it. But if you notice, it's putting this 1 on the right-hand side of the column. Oopsies. So we don't want that to happen. We want it to be justified to the left-hand side of the column. So we can put left. Let's not put it after setw. Well, let's put it after setw. Because maybe you can just put it there. Maybe not. Let's see what computer science is about. Let's compile it and run it. And it does work. So this setw, it's not going to take other manipulators. This is from, not from the iomanip library, actually. It's actually from a library called iOS. But it's a iomanip manipulator type. Because as you see, it justifies our number to the left. And just like if, say, later on in your program, you wanted to shift it back to the right, you could say right and then compile your program and run it, and it will justify to the right. So let's also go over set width or setfill, which could be something like, say we want to output, let me comment really quick, actually. So say we want to output something like, I don't know. Let's do a set width of 25. And then let's justify it to the left and output, I don't know, book 1 or chapter 1. And we'll say that is on page. We'll just do a set debut of 10 for the page number. And let's say that's on page like 1. And then see out. Let's not keep writing the same line of code over and over again. Let's just do like. Is this not work? Okay. 1, 2, 3, 4, 5. We'll do 6 chapters. And let's do 5 whoopsies. 1, 2, 3, 4. 5 chapters. Chapter 5. Let's. This isn't gonna work. Let's just keep skipping. So like chapter 10. Chapter 100. I'm just trying to do this for the sake of like things moving and there being different lengths. Chapter, whatever number that is. And we'll say this one starts on page this number, and this one starts on page this number. Yeah, I mean, the numbers don't matter, but they look really weird to me, so I don't like it. Okay, and this one starts on this number, and this one starts on this number. Cool. Let's save that and run it. Woo! Oh, that's because I'm not writing the right thing. See, look, but this is great. Look at all these errors. Looks like a ton of errors, but look, they're all just the same error over and over again, where there's no such thing as set. It is set width. So we can compile that, clear out all these errors, and run it, and it outputs all weird, but what the heck? Oh, that's fun. So we can run it, and for some reason because I'm not doing this. Sorry. Good programmer, eh? See, that's a semantics error right there, though. So it's good for you guys to see these things. Because look, why is it all just outputting on one line like this? Because I didn't put in end lines. So I think I just put in, okay, yeah, I didn't put in 2 semicolons. So let's clear that atrocity. Let's compile. And then let's run. And you see we get chapter 1, chapter 5, 10, whatever. But if you have like a million bajillion rows of this, it's going to be really hard. And like, say this is spaced out even more over. It's going to be hard for you to see which ones of these, which page these are on. So what you can do is say setfill, period. And what that's going to do is in all these blank spaces that you don't use, because you see there's a bunch of blank spaces because this doesn't fill up 25 characters, it's going to put a bunch of periods. So let's clear this, compile, and run. And I didn't save. So let's save, clear this, compile, and run. And you see you get a bunch of periods that output. And you notice it will give us periods here as well because we're set filling here or set widthing here. So what we would want to do is do a write, because this looks weird. We don't want the periods that way. We want the periods on the other side. Right. And let's not keep typing the same line of code over and over again. Right. We can compile and run our program, and you see we get nice dots that lead to the page numbers. That's how you can use setfill. So this isn't just a setfill example. Setfill, right, left, and that's it. Okay. And then we also need to talk about setprecision. But before we talk about setprecision, let's talk about fixed scientific and showpoint. So fixed is going to be if you have something like, let's do scientific first. Let's do fixed and scientific at the same time, and then we'll do showpoint in a second. So let's do cout fixed 1 point some dump of numbers end line, and cout scientific that same dump of numbers after 1 point and then end line. So we don't want this right now. We can compile and run our program, and you see we get 1.123434 as our number output here. But in this case, we get it in scientific notation. So if we did something more like, let's just move the decimal to here, the point, and then point. That's a bad example. We can clear, compile, and run our program. And you see we get the normal floating point number we'd expect printed out there. But in this case, we get it in its scientific notation form. So if you're getting numbers that are spit out in their scientific notation form, you can just use this fixed operator to get them to show as their normal decimal form. And if you have them in their normal decimal form and you need them to be in scientific form, you can just use this scientific operator to change that. And then also, there's one more that we have. That's going to be showpoint. Showpoint is going to be if you have something like double, example, double, we'll just say double number equals 1.0. If you cout denum, what you're going to get is, oopsies. What you're going to get is just 1 because you have the 0.0. But if, say, you want that 0.0 to output, you can just say showpoint and save, compile, and run your program, and you get the decimal points. But say you see how there's like all these extra trailing zeros. Say you don't want those. You can just say something like, what is it? Set precision 2. And compile and run your program, and it will output 1.0. But if you notice, I said 2, and that said 2 as in this number, then this number, not 2 decimal places, as in my head, that's what I wanted it to do, was show 2 decimal places. Because it's in scientific right now. We need to switch it over to fixed. So when we do that, compile, and run our program, it will give us two decimal places. And that's all you guys need to know from iomanip.